Hello, Algebra 2 students. So in this lesson we're going to review graphing inequalities in, you guessed it, 2 dimensions. Alright, so you should have already done this in Algebra 1, so this is going to be another kind of quick lesson before we get to some new material this year. Alright, so the first example is to graph the inequality y is greater than or equal to 7. So this one doesn't jump out at you as a two-dimensional problem, like example 2 should because it has x and y, or example 3 that has both x and y. Those clearly, whether directions tell you or not, are inequalities that you need to graph in 2 dimensions. This one's different. It's just y is greater than or equal to 7. So let's think about our coordinate plane and think about some points that might satisfy that condition. So think about any point that's equal to 7 first of all, because this says greater than or equal to 7. So a point that's like equal to 7 might be up here, right? 4, 5, 6, 7. That's 5. So there's one point that's equal to 7. So now imagine another point, any other point will do, where the y-coordinate is 7. So in my class today, a couple people said things like 7, 2. So for instance, right here. So any 2 points, of course, make a line, so this should bring you back to the idea that y equals is a horizontal line. So there's y equals 7. But that's just y equals 7. So now you want to think about other points that could be greater than that. So any point on this edge would work. But I think there's other points as well. So think about another point that's just plopped down, like this one. Would this point be greater than 7? No, its y-coordinate is like 4. So that's not one that would work. How about one down here? Well, of course, its y-coordinate is a negative, something like negative 3. So that one is also not going to work. How about this guy? Yes. How about this guy? Yes. Or this guy? Yes. All of these things work. So any point that's up in this region up here, above our line, is going to be an answer. So a couple pieces of vocabulary that you definitely need to know here is that this region of answers we're going to call the solution region. Sometimes you'll also see it referred to this year as a feasible region. So a solution or feasible region. Okay, so that's the first piece of vocabulary. The edge you can call an edge, but sometimes we have another name for it. I more commonly will call this the boundary of the solution region. Okay, so that's also called a boundary. So there's our first example. We're done. So don't get mixed up with x equals as vertical lines and y equals as horizontal. It's real easy to do. Notice, how did I do this problem? I just plotted one point with the y of 7 and another point, and I clearly didn't know. I clearly knew that it was a horizontal line. You can't mix those up as we go forward. Alright, example 2. We need to graph this one. This one's not horizontal or vertical. I think we need to solve for y, right? It should be something that looks really familiar to you by now in Algebra 2. We need to solve for y by getting y by itself. And then we can use mx plus b. So I'm going to move the x's out of the way first. We'll see what's left. So it leaves negative 5y. It's less than or equal to 10x plus 35. Now it doesn't matter which one of these two things that I put first. I could have said 35 plus 10x, just as good. Okay, y is not by itself. I need to divide that negative 5 now, so I'm going to do that. Divide it through evenly all the way on both sides. So on the left hand side I just have y. I divided by negative numbers, so I need to flip my inequality the other direction. It's like I turn my car around. Here I have negative 2 when I do 10 over negative 5. There's an x stuck to it there. And 35 over 5 is 7. Negative 7 to be precise. And now we're ready to graph this one. So let's graph this solution region. You can tell that I'm really great with my pad. Oh man, at drawing graphs. I'm going to have to start getting some ready in advance. Just haven't done enough of them, it looks like. So I'm going to think a little bit ahead and graph it like this. So here's my xy plane. If you want to label this as xy because you get them confused, then do so. It's up to you. You just got to not make a mistake. So our launch pad, our y-intercept is negative 7. So 1, 2, 3, 4, 5, 6, 7. So there we go. We need to go down 2 from there and over 1. So down 2 over 1, and this is the line. Now, I want to be solid again because of this equals right here, right? If that equals wasn't there, I'd have to make my boundary dashed, but I think we're equal to it this time, so there we go. Kind of a not the best boundary, but there you go. So now I want to shade in my solutions. So you can think about this a couple ways. You could again play the game of toss down a point anywhere and put the x and y coordinates of that point into this or into this and see if it's true. If it was true, then you'd shade over here. If it was false, then it would be everywhere over here. So that's one way to approach that. That's never been my preference exactly. So instead of doing that, I'm just going to read this right here. This really says y is greater than, so I'm going to interpret that as above my line. If it was less than, then it'd be below. And above my line is clearly this area over here. This is all above my line. So all this stuff, any point in that region is a solution. So there you go. There's a second example. So I might ask you at this point to pause the video and try example 3 on your own after I give you this first hint. So in the last couple lessons, we've been pursuing a variety of ways to solve equations and inequalities. This one's no different. You could do this problem a variety of different ways. Usually in my class, the first suggestion is distribute, something like this. Distributing will easily get this problem solved. Well, I shouldn't say easily, because you're going to get 12/5 and -6/5. And those are kind of ugly fractions. So I think you should apply the same strategy that I've shown you in other lectures. So a better choice here is think about the fractions. There's only one right here, right? And you really don't want that 5. You'd like to cut it off. So multiply by something 5 goes into. Like 10, 15, or more simply, how about 5? Doesn't 5 go into itself? Yeah, 5 totally goes into itself. So I'm going to take that 5, and I'm going to multiply both sides of the equation by it to cut off my fractions. That worked in proportion land. That worked when we were solving linear equations that had fractions in them, and it's still going to work when you're working with inequalities that have fractions in them, and a large variety of those, by the way. They don't even have to be linear. So I hope that you'll take that piece of advice to heart and chop off your fractions. So let's see what's left in this problem. We've got our 3, we've got 4x minus 2y, and over here now we have 15. So now I'm going to either distribute that 3, you could do that, or you could divide it to the other side since it's multiplying this side. This time I think I'm going to divide because 15 over 3 is a nice number. It's up to you. I'd consider dividing first, and if it's not a nice number, maybe distributing is a better choice. It's all about doing mathematics intelligently and doing less work, not more. So now I just need to solve for y and graph it. If you're watching the video right now, I'd definitely take it from this step right here and try to finish it up yourself. Then unpause the video and check your work, see if you made any mistakes. Alright, so let's see what's left. I have negative 2y, and on this side I have 5 minus 4x. I'm going to divide that negative 2 on both sides, making sure that I do it everywhere. And I'll get y. Did I divide by a negative number? If there's a negative in here like this one, that doesn't matter. It's because I divided by a negative that I have to flip the sign. So I think I'll get, what is that? 5 over negative 2 plus 2x. Well, that might be better to turn around just to make myself feel better. It's 2x, and 5 over 2 is 2.5, right? So I'm going to say minus 2.5. So there we go. And then we could, of course, graph this guy, which hopefully you've already done because you paused the video. So I'll just graph it real quickly. So let's see. I'll just do this one in red. So negative 2.5 is the y-intercept. So if that's negative 3, there's the y-intercept. Need to go up 2 over 1. There we go. This line does not have an equals under it, so it's going to be transparent. The boundary on this problem is dashed. And I think I need to shade above again because it says y is greater than. So all this region over here is my solution region on this problem. One final example. We really need to make sure we're comfortable with basic word problems. This I would call a word problem, this kind of application. We're going to be working with these quite a bit, and they will compose a large portion of your grade on this assignment. So definitely don't skip them or try to avoid them. You definitely need to get into them. So let's have a look. It says we've got a school carnival. Adults pay $4.50. Children pay $3. And that's what their fee is for getting in. The school needs to make at least $135 to cover expenses for popcorn and whatever else they need at the carnival. We're supposed to write and graph an expression for these solutions, for any solution to this situation. Okay? So, like I've discussed in class a couple times already, what's really key is that you define your variables. What do you want x and what do you want y to be? Now you could say a for adults, and c for children. That would totally work as well. But then you're going to have to graph on the AC axis, and I don't think you're going to be very comfortable with that. So let's target eventually graphing on our plain old XY axis that we're used to. Okay? So X and Y. So what are X and Y going to be? Looks like the thing that's changing here is how many entrance fees. Oh, so this is like tickets, right? So I think that we could add the word tickets and clarify a little bit. So we've got should we say X is adult tickets? Doesn't really matter which one you do for which. Doesn't matter exactly what you put here. What matters is that you put something to clarify the situation in your own mind. Okay, so now I need to work these together. So I think we're paying $4.50 for the adult tickets. That's times each X. Then adding that to the money we have to pay, well, the money we get from the tickets we sell to the children. And then we got to compare that to $135, right? There's just one comparison here. So if you're not sure what at least means, you could just guess. You could just be like, blah. So there's a guess. Now read it back to yourself. This is the money from the adults. This is the money from the children, and it says it's less than $135. Is that going to be at least $135? I think if you sit there and read that to yourself once or twice, you're going to be like, well, of course not. It's definitely got to be the other way, right? So it's got to be this way. Now, do we put an equals under here or not? Would it be okay if it was exactly $135? You can see how I'm rephrasing it to myself several different ways. So rephrasing is key here. So I think exactly equal work. So there you go. So if you're watching, I'd pause it and graph this solution region. And I'm going to show you a little bit on the calculator here, so hang with me. So we'll graph this guy by hand first, just do a quick rough sketch the same way we've done the other ones. So I'm going to do that. Here's what you'll get. Divide by my 3. At this point you might want to go to your calculator, and that's okay. So I'm going to say, what is negative 4.5 over 3? So you go to your calculator, that's negative 1.5, I'll tell you though. 135 divided by 3, I'd have to think about that one. So I'm going to go to my calculator here, and I got 45. Okay, so let's do a rough sketch of this graph. We'll say the y-intercept is 45, so up here we'll call that 45. And now I'd like you to think about if 45 is down here on the x-axis, is our line going to go down and go through that 45 like so, or is it going to be steeper, or is it going to be shallower? So that's what you want to think about. Which one of those options is it going to be when your slope is negative 1.5? Remember, negative 1 slope will go down 1 over 1, down 1 over 1, and continue all the way down to this 45. So is negative 1.5 steeper than that, or shallower than that? Well, if you learned anything in Algebra 1, hopefully you remember it's steeper than that. So that means it's going to go and somewhere intersect down here. I don't know where it's going to be exactly, but it's going to be down there. Now we can already kind of finish this problem up and say, do we want to shade above or below? So reading it right here, I think I need to shade above. So my solutions are going to be all of these guys above the line. A couple things I want to make a little bit more precise on this problem. Number one, there's some points in here that don't make sense. I don't think this point could be an answer, or this point over here. I think, in fact, I need to erase this whole spot over here and this whole spot over here. Now, why is that? Well, let's remember our green 45 that we said we guessed it went through before that. I think that's because you can't have negative tickets. You can't have negative adult or negative child tickets. Only this region out here is going to count. Now the last thing I want to do is find this actual x-intercept. We think it's less than 45. Let's use our calculator to refine our guess. So remember your line is negative 1.5x plus 45. Let's pull up our calculator. In fact, we might even be able to fit it in the window here. Here we go. So the first place you want to go is to y equals. So click this button in the top left, y equals. Now we're going to put in our equation. So press negative 1.5, and x is right here by the second key. Then you're going to go plus 45. And if you learned anything about with your graphing calculator before, or if you're doing it for the first time, you always want to start by going zoom standard, or zoom 6. Now that's going to start you at 10 in each direction. So you are saying, well, where's my line? Come back to your line over here. I thought we were supposed to see this, right? Well, I think it's too far up, right? We need to go to our window and change it. So it's really important that you get used to working with and get comfortable with your window. So we need our window to go higher. So the y max needs to be more than 45, right? Let's make it like 60. Instead of scaling by 1, let's scale by 10. And we said that we thought the x-intercept was going to be something like 40, a little less than 45, but we need it to be farther. So maybe I'll just go 60 in this direction too. Scale that one by 10. Now if I hit graph, I think I get the kind of graph we were seeing. So what we're really going to do that's very important here is we're going to have the calculator find this x-intercept, or in other words, 0 for us. An x-intercept is also called a 0. So hit second, trace, in other words, calculate. And you'll see a menu with lots of different options. We'll be using a lot of them this year. We're right now interested in a 0. And now it's going to pop up the cursor and it says left bound. So get down close to that thing you're trying to get and go on the left of it a little bit. Something like right there. And then scroll to the right side of it. Maybe something like down here. That's on the right side of the 0. And finally you want to scroll it up to where you're close to where the 0 actually is. It says guess. We'll guess right here. And it says, in fact, that 0 is at 30. So let's go ahead and write that down in our problem. This x-intercept was actually 30. So that gives us a nice scale, and you just figured out how to use your calculator to find zeros and how to manipulate the window. Those are all vital skills which we'll be using very soon in a variety of lessons. So I would definitely practice them on this assignment in the applications. I'll see you next time when we look at more new kinds of inequalities.